On page 4, please paste this foldable you got in class today and cut along those black lines after you have folded it correctly. Please put the number 4 for page 4, but you don't have to put a title because it's already on your foldable. We're talking about average rate of change. If you remember from your Algebra 1 days, average rate of change, another word for that is also slope. And we know that if you're talking about a linear function, a line, then that slope is going to be constant between any 2 points. In addition, we also know that for a non-linear function, then it's going to change. We saw that in class today where it's going to vary from one section to another. So it may be different between any 2 pairs of points. You should also remember that when you have a positive rate of change, this means your y values are getting bigger, which means your graph is increasing from left to right as x gets bigger. If you have a negative rate of change, this means your y values are getting smaller as your x gets bigger, which means your graph is going down or decreasing from left to right. Now, on the right side of that tab, we're going to write down the formula for slope. If you remember, we use the letter M to represent slope. We call it rise over run, which some of your Algebra 1 teachers may have said that this was also the same thing as delta y over delta x. The Greek letter delta means change in, so they may have also said change in y over change in x. And the way that we represent that mathematically is y2 minus y1 over x2 minus x1. Now, since y can also be represented by f of x is the function notation, we can actually change this slightly from your Algebra 1 to Algebra 2 class so that it has the function notation that's being used instead. So please remember, f of x is the same thing as y. So if I'm going to do this interval from a to b instead of from x1 to x2, when I plug in that a, I'm going to get f of a for my y value, and when I plug in that b, I'll get f of b for that y value. So I'm still doing y2 minus y1, I'm just changing the way that I write it as f of b minus f of a, and I'm still doing x2 minus x1, it's the same calculations, I'm just changing it the letters to b minus a. If you will, open up the next tab where it says you're finding the rate of change given a graph. So the directions say to calculate the rate of change from 0 to 3 and then again from 11 to 14. So if I go to the point 0, that y value is 48, so that's going to be one of my pairs of points that I'll use. If I go to x equals 3, that y value is 106. So I'll choose to let my 0, 48 be my a f of a, but please know it could have also been 3, 1 over 106. It actually doesn't matter the order in which your a and b go, as long as you put a with f of a and b with f of b. So that means I'll call 3, 106 then my b, f of b. So if I use that formula that I was using earlier, this is going to be my f of b, 106, minus f of a, which is going to be 48, divided that by b minus a, which is 3 minus 0. When I do that, I get 58 divided by 3, which is approximately 19.3. Please remember I said that you are not going to want to just simply write 19.3. You're going to use your x-axis and y-axis labels to give a little bit more information. In this case, it says the number of pairs of shoes sold, so I wrote 19.3 shoes sold. And then the time is in hours, so it's going to be per 1 hour. So if I want to explain that meaning then, I could say the store sales increased. It's increased because it's a positive 19.3. Don't forget we have to write that word on average because it's not the same slope or the same rate of change between 0 to 1 as it is from 1 to 2 or 2 to 3. It's going to change from hour to hour. And so as a result, we have to say the words on average. On average by 19 shoes per hour. And finally, you have to tell me when, because you could have done it from 11 to 12, you could have done it from 7 to 10, and so forth. So the interval in which you calculated that, since these rates of change are changing through each interval, you have to be very specific as to which interval you used. So I wrote from when it opened to 0 to 3 hours later. And that would be sufficient for your explanation. And then if I do the exact same thing for 11 and 14, I used 11,72 as my a and f of a, and I used 14,0 as my b and f of b. Now, I just kind of estimated some of these points, like the 0, 48, the 3, 106, and so I just estimated the 3, 106. So if you don't exactly have 106 like me, or if you don't have exactly 72, it's okay as long as it's close. So now when I go to do my slope this time, I'll again set up my y2 minus y1, or f of b minus f of a, over x2 minus x1, or b minus a. When I do that, I end up with negative 72 over 3, which then gives me negative 24 shoes sold per hour. This time I have a negative, so I'm going to say the store sales decreased instead of increased, on average by 24 shoes per hour from 11 hours after it opened to 14 hours after it opened. And this tab is now done. So if you will now please open up your table tab, finding the average rate of change using a table. And so we've been given a table. It says the x-axis represents the weight in pounds and the y-axis represents the length of the spring in inches. And it wants me to explain the meaning of the rate of change from 0 to 1.5. So if I use the point at 0, it's 4. And if I use the point at 1.5, it's 6.4. So when I set that up as my y2 minus y1, or f of b minus f of a, I'll get 6.4 minus 4. And I'll divide that by my b minus a, which is going to be 1.5 minus 0. When I divide those two numbers, I get 1.6 inches per 1 pound. So the 2.4 divided by 1.5 was 1.6. This is really over 1 now. So this is 1.6 inch divided by 1 pound. And to explain that, it says this is the length of the spring, that's the y value. The length of the spring increased on average by 1.6 inches for every pound of weight added between 0 and 1.5 pounds. And then that page is now done. And then the last page, we're now going to find the average rate of change using an equation. So we have a population of rabbits, p of x, and it can be modeled by the function p of x equals 20 parentheses 1.014 to the x power. Now for you, I put a caret key and an x. I went ahead and changed mine so that it had to the x power, so I didn't have that little caret key there. It says x represents the number of days since the population was first counted, and it wants to know the rate of change from day 10 to day 20, and then a second rate of change, what is it, from 40 to 50 days later. And then we want to explain what each of these represent in relation to the situation. So we talked about in class, when you're not given the y value, but you're given the formula, you can go ahead and plug in the x values that you need. So it says from day 10 to day 20, so this will be my a and my b, or my x1 and my x2. I'll plug this into my calculator, so 10 will replace x. Since this is an exponent, I'm going to use the caret key on my calculator, which is right above the divide symbol. And the way that I write that is p of 10, x got replaced with 10, is equal to 20 times, this is technically times, so a parenthesis 1.04, and then the caret key, and then the number 10. When you do that, verify that you got 22.98. And then I'll do the same thing for p of 20, and I got 26.41. I now have my f of b and f of a, and I can now use my formula to set up my rate of change. So I've got p of 20 minus p of 10, that's my change in y, divided by 20 minus 10, which is going to be my change in x. And when I do that, I get 3.43 over 10, which is approximately 0.34 rabbits per day. So for that explanation, we've got a population of rabbits that are increasing. Again, it's on average by 0.34 rabbits per day from day 10 to day 20. Now, I understand I can't actually have 0.34 rabbits, but I didn't want to round it down to 0 because that wouldn't make sense at all. And I didn't want to round it up to 1 either because that also wouldn't make sense in terms of this problem. So I went ahead and kept it as a decimal. If this would have been, like, for example, 2.34 rabbits, I would have rounded it down to 2 rabbits. But because of that 0.34, I'm actually going to leave this as a decimal, even though it doesn't make complete sense as of right now, because you can't have 0.34 rabbits clearly. Now, if I go to do my second rate of change from day 40 to day 50, p of 40 is 34.88, and p of 50 is 40.08. So if I follow that formula again, I end up with p of 50 minus p of 40 divided by 50 minus 40. That gives me 5.2 divided by 10, which is going to divide into 0.52. Again, I have rabbits per day, so my population of rabbits are now increasing on average by 0.52 rabbits per day from day 40 to day 50. So you can see, even though they both have had a 10-year span from day 10 to day 20 and day 40 to day 50, these rates of change are not the same. So that's why we had to use that word on average. And you'll also notice that over that 10-day period, later on as time goes, the number of rabbits is actually going higher than at the very beginning. This is because this is an exponential function, and it's going to increase a lot faster the more days that get counted. And so these numbers for your rates of change will continue to grow as the number of days also increase. And that's it for this page.